Hello everyone, welcome back to my channel Prince Automation Destination. This is Prince. So today we are going to talk about another important Java collection, that is stack. This is one of the most widely used data structure internally by all the programming language. First, to keep track of exception stack trace. So whenever you see an exception, you see the stack trace of exception. So same is managed using stack. Secondly, it is used to keep track of method invocation. What does it mean? Meaning whenever we work in any programming language, we create multiple methods and we make call to one method from another method. So stack is internally used to keep track of that particular method invocation, right? From test automation point of view, we will find very rare use cases we can utilize stack, but it is going to help us in solving some of the programming problems. So now let us try to understand what is stack. So stack is a collection which is used to insert the item at last and used to remove the item at first. What does it mean? So for example, we have this particular diagram. So whichever the item which is getting inserted at top, that will be removed first. So for example, we have a packet of biscuit. So whichever the biscuit that is getting inserted at top, that will be removed first, right? So if we have any such requirement, so at those places we can use stack. So let us read more on this. Here the element which is inserted at the last will be removed first, and stack extends vector, which is a legacy collection. So as a result, stack also become a legacy collection. DQ is generally preferred over stack. So DQ is a combination of queue as well as stack and is more efficient than stack. So whenever there is a requirement to use stack, so we can always use DQ as well. Now let us talk about the different methods. So push, pop, peek, empty, and search. Push is used to add the item at the top of the stack. Pop is used to remove the item from the top of stack. Peek is used to get the top item of the stack without removing it. And empty to check if the stack is empty or not, and it will return boolean. Search, it is used to return the position of element in stack from top. If the element is not available, which we are trying to search, it will return -1. So now let us try to demonstrate it and try to understand each of these methods. So for demonstration purpose, what I have done, I have created one sample class, and here inside main method, let us create one stack and let us store integer and give it name integers stack. This is how we can write stack. So if we go inside this stack, it is extending vector as we just discussed, and vector is extending abstract list, which is implementing list. So we can say stack is an extension of list, right? So how to store the element? So to store the element, we can use push. So let us insert second item 1 3, and let us insert another item push 4. So if I'll simply print this particular stack now, this stack should have these entries. So we see this stack has 1 3 4. Now to remove the item from the stack, right, we can use pop, right? And as we discussed, that whatever is inserted at top, that will be removed first. So 1 is inserted first, 3 is inserted then after 1, and 4 is inserted at last. So when we will use pop, so 4 should be removed, and here into the stack should be reduced by 1 value, and it should contain only 1 and 3. Let us try to execute it. So you see we are getting 4 and we are getting the stack as 1 and 3, meaning the last item has been removed. Similarly, let us use peek. So peek is used to get the last item, but it won't remove the item from the stack, right? Let us confirm the same. So we got 4 when we call peek, and we have stack still has, meaning the stack still has all the values. We haven't removed any value. Similarly, we can use another method, empty. So we see we are getting false because stack has some values. That's why we are not getting true, right? Similarly, we can use another method, that is integer stack dot search. So search is used to search some item. So if we will talk about 1, right? So 1 is inserted first, 3 is inserted, and 4. So whenever we are going to use search, it will calculate the position of the element with respect to the top element, right? So let us try to locate 1. So 1, what would be the position of 1 with respect to the top item, which is 4, right? So it would be 1, 2 and 3. So we should get 3. So you see we got 3, right? If for example instead of 1, let us try to locate 3. So it should give 2 this time. Okay, and if we'll try to find the top element, it will simply give 1. And for example, if we try to find any item which is not available in stack, it should give -1. So this is how we can utilize stack, and these are the different operations that we can utilize in stack. Now there are different considerations and alternatives related to stack. So as we just discussed, that it is getting inherited from vector, which means all of its operations are synchronized, because vector has all methods as synchronized. So this can introduce unnecessary overhead if thread safety is not required. In case we are not working in multi-threading, so usage of stack will make unnecessary overhead and it would have performance constraints, right? So better alternative is WQ or DQ, double-ended queue interface, and its implementation like ArrayDQ, which provide a modern and flexible way to use stack operations in Java. ArrayDQ is faster than stack because it is not synchronized and is specifically designed to be used as both a stack and queue. So wherever we have a requirement to use stack, so we can always go for ArrayDQ, which is an implementation of DQ interface. So this is what I wanted to cover, guys, as part of one lecture. Thank you for watching. I would request you to please like, share, and subscribe. Thank you once again.